In this video, we are going to look at a few new terminologies for isomers of alkenes. So the first example I'm going to put is isomer of butene. And I have few of them and I number them 1 to 5. The first one is easy. So there is a double bond on the first carbon and between first and second. 1, 2, 3, 4. So it's C4 and you have 8 hydrogens. So in order to name it, we have to number the carbons. The carbon on the left should be carbon 1, 2, 3, 4. So this is 1 butene or but1-ene. So but1-ene, and that's the first one. Then we can take one of the carbons and make it as a branch and put it on the second one. So we still have a CH2. Here, this carbon should have no hydrogens. There is a CH3. There are 4 bonds, and it's good to go. So in order to number it, then the longest continuous chain is 1. This is carbon 2, 3, and this is a methyl branch. So I have a 2-methyl, 1-propene, or prop1-ene. So name it 2-methyl, prop1-ene. It's still an isomer of butene. Now things will get a little bit new for you guys. What I can do is put the 2 CH3s on one side and the 2 hydrogens on the other side. If you have a structure like this in chemistry we refer to it as cis. So cis are those isomers that the like groups like CH3s are on one side of the carbon. The double bond is rigid, you cannot break it, so you cannot rotate this. So we call this just cis in order to say CH3s are on one side, but it's still, you have to number them. So this is 1, 2, 3, 4. So the double bond is on the second carbon. So we are just going to put an attribute of cis in front of it. And then we call it but2-ene or 2-butene. Cis but2-ene. So cis indicates that there are 2 like terms on one side of carbon. Now if you put them on the other side, which is the structure number 4, if you put one CH3 on one side and then the other CH3 across from it, we refer to this as trans, and you can just remember transatlantic, across from each other. So it's almost like number 3, except this has attribute of trans in front of it. Trans but2-ene. So trans means across from each other, cis means on the same side. Finally, you can also make a structure that is a ring structure. If you look at this structure, you have 4 carbons and you can only put 2 hydrogens on each junction, which I have it like this. So if I spell it out a little bit more, it's CH2 attached to a CH2. There is a CH2 down here. So it's a cube CH2 and everything is connected. For this structure, we call it cyclo. So every time you have a ring structure, you call it cyclo. So this is cyclobutane. Now the ending is ane because it's also saturated. There is no double bond in it. So for something that has structure of a alkene, you could also have a cyclo alkane version of it. So all 5 of these structures are isomers. Now let's do a little bit more practice. On the next page, I'm giving you some names and then we are going to make the structure. The first one is cis-3-hexene. So the 3 is indicating that's the location of the double bond. So I'm going to put my double bond and imagine this is carbon 3. Since I know it's cis, they should be across from each other. So what I'm going to do is put 1 hydrogen below, the other hydrogen is also below, and then I'm going to put CH2, CH3, CH2, CH3. You have 1, 2, 3, 4, 5, 6. So that's hexene, and it's on the carbon number 3. So it's 1, 2, 3, 4, 5, 6. if I give you the stick model of it, it just looks something of this notion. So this is the cis version of it. The next is saying, what about the other isomer, the trans? So the trans should be across from each other, so the structure looks something of this notion. If we need to spell it out, we do that. So there is a CH3, CH2 attached to a carbon, double bond, carbon. There is CH2, CH3. Don't forget to put another hydrogen because you need to have 4 bonds for each carbon. So that's the trans version. Now, what about cyclohexane? So cyclo will say it's a ring. Hex will say there are 6. And ane, the last name of ane is saying it's saturated. So we are going to put a ring structure. So you have 1, 2, 3, 4, 5, 6. So this is cyclohexane. If you want to spell it out, there is a CH2, CH2 here, CH2, 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 and then CH2. And you connect it. That's cyclohexane. Now if you look at this, these are only a few isomers of C6H12, which is hexene. So these are isomers of hexene. To just recap few ideas is, one is that you have cis and trans isomers for alkenes. When you have cis, that means the 2 like groups, they could be CH3s or even halogens, bromines, they happen to be on the one side of the double bond. So when you have a double bond, the 2 like groups are on one side. If you have trans, then the two like groups are across from each other. So this is a trans that looks like this. So the 2 like groups are across from each other. Finally, you could have Cyclo Alkane, which contains a ring structure, and I'm giving you a few of them that it's important to remember. So cyclopropane is C3H6. So that's one isomer of propene. Cyclobutane is C4H8, which we looked at it. It's just a square. And then cyclopentane. And you have cyclohexane, for just knowing a few of them.